Okay, so we are talking about schedule management and time management for the project. We already finished Gantt chart, and now we are discussing the other methods of evaluating project timeline, CPM and PERT, critical path method, and program evaluation and review technique. Okay, so we have discussed the introduction of the PERT technique, some definitions, what is task, activity, duration, critical path, and so on and so forth. Now this is where we stopped. Okay, now it could have been much better if I was doing it on a board or something. Okay, but try to follow me. Okay, try to follow me. If you have any questions, you can stop and ask me, because this is the most critical part of this analysis. If you understand this, then everything else will be good for you. Okay, so this is the what we call as an activity on node diagram. So A, B, C, D, E, F, G, H, all of them are activities of the project. This is what you identify from the WBS. So WBS, you already divided the project into activities, and this is each activity. Okay, and then we have earlier talked about dependencies as well. Okay, so what is this diagram showing? Activity B cannot start until A finishes. Activity F cannot start until A finishes. Until activity H cannot start until A finishes. Activity C cannot start until B finishes. So the arrows are showing the dependencies. Okay, that this activity is depending upon this one, and this one is depending upon this one. Okay, so you can see activity A affects three activities: B, F, and H. Activity C affects G and D only, and G is also affected by F. And activity E is depending upon three activities. Okay, so the arrows, wherever they are showing the dependencies. Okay, I believe there are some other examples where we can do it on our own as well. We can make this diagram, but first of all, try to learn how this diagram or what this diagram is showing. Okay, so now on top of each activity, you see its duration. So this is duration of activity A, for B, for F, for C, and so on and so forth. Okay, so the letters are activities, arrows are dependencies, and duration is on the top. Okay, now start the analysis. We start with putting early start and finish times. The first thing which we will do is put early start and finish times, which you can see in green color here. On each, with each activity, you see the early start and early finish. Okay, what is this? Early start means the earliest this activity can start, and the early finish is early start plus duration. Okay, let me write it here. Early start plus duration equals to early finish. Okay, so you start the first activity. Early start of first activity always 1. Early start first activity always 1. Then you will add duration in it to get the early finish. So 1 plus 10 equals to 10. Okay, now you are not doing it, so 1 is counted. Okay, 1 is counted because 1 is the day when it will start. So you will start working on day 1. So you have to count day 1 as well. Okay, so you will not do 1 plus 11. You are doing basically 0 plus 11 or 0 plus 10. You are not doing 1 plus 10. You are doing 0 plus 10 because 1 is counted in working. Okay, on day 1 you already started working. Okay, now from this onwards you will look at the arrows. So arrows from A go to F, B, and H. So these arrows will give us the early start for the next activities. Okay, so A finishes on 10. After A, F can start. So early start of F is 11. Can it start before 11? No, because it has to start after A, and A does not finish till 10. Okay, so F has to start at 11. Same thing with B, same thing with H. Okay, it cannot start until all the arrows before it has been finished. Okay, so it has only one arrow here which goes to A, and A finishes on 10, so H can start at 11. Okay, so 11, 11, all of them. Then you will add the duration, and again you will add it including 11, including 11. Okay, so basically from 10, from 10. So 10 plus 15, 25, early finish. 10 plus 20, early finish, 30. 10 plus 15, early finish, 25. Okay, so you got the early finish for the next activities. Okay, same thing will happen for C. Okay, now so you can see, 30, then 31 plus 5, 30 is, there's some problem here, I believe. 31, correct. And yeah, I believe there's a problem. This needs some correction. Okay, so 31 is fine. Then 31, this should be 35. Okay, this should be 35 and this should be from the next year. Okay, so I will correct it. Okay, but this is correct. Okay, so where was I? Yeah. So for activity G now. Okay, now activity G is depending upon two things, F and C. F and C. Now F finishes on day 25 and C finishes on day 36. Okay, now it should be 35 basically. The problem is here. This one should be 35. Then this will all make sense. So this one should be 35. You can correct it in your notes or something. This one should be 35. Okay, so after 35, G can start. Okay, so from here, the early start for G is 35. After 35, which is 36. Okay, and from here, it can start from 26 onwards. So on 25, F will finish, and then the next one can start from 26. Okay, so from here, I'm getting 36, and from here I'm getting 26. Okay, now if I go for 36, okay, I'm satisfying this one and this one both. Okay, because from here I was getting 26, so after 26 any day is fine. Okay, but before 36 I will break this rule. I will break the condition of this arrow. Okay, so I have to put 36 here. Okay, I have to put 36 here. Let me see. No, it will not happen here. So sorry for that. The marker will mess up this diagram. Okay, so I was getting 26 from here and I was getting 36 from here. So I went with 36 because 36 satisfies both of them. Okay, is everything clear up till now? Do you guys have any questions? Okay, so moving on. So in the same way, you will go to activity. So I'm jumping now. You go to activity E. So this one finishes at 40. This one finishes at 45. This one finishes at 25. Okay. So if I go with 41, I will break this arrow and yeah, this one. If I go with 26, okay, I'm breaking this rule. So I have gone with 46. Okay, so all three are satisfied. Okay, so you have to put the early start which satisfies all the conditions, all the dependencies. Okay, this is the point. Okay, so 46 plus duration 65. So including 46 itself. Okay, including 46 itself. So you will get 65 here. Okay, so now we have put the early starts now. Early starts are put. Now I will start putting the late timings now. Okay, So the one in green are called early start and early finish, and the one in blue are called late start and late finish. So early start, I told you. Let me recap. For early times, I started from node 1, day 1. Then I added duration, I got the early finish. Then I moved to the next activities and looked at the dependencies. Whichever early start satisfies all the dependencies, I put that one, add duration, get the late early finish, and so on and so forth until you get to the end. Now the number which you are getting in the end, 65, is the duration of the full project. So the full project has all activities from A to E. Okay, so when E finishes, all the whole project is finished. E finishes at 65. So 65 becomes the duration of the project. Okay, in other words, the early finish of the last activity in the diagram is the duration of the project. Okay, so I will start now from the last activity. So for early, I started from the first activity. For the late, I will start from the last activity. Okay, so I'll start from here. Okay, now I'll do the reverse. So the late start of the first activity is the duration of the project. The late finish of last activity equals to duration of the project, which you got from the early finish of the same activity. Okay, then you start subtracting to get the late start time. So late start equals late finish minus duration. So we are doing the reverse now. Okay, we are doing the reverse. Okay, 65 minus 20, 46. So 46 is here. Again, you have to count 46 as well. Okay, now if I go back from this, I can put the the late finish. Okay, from here I have to put 45, right? I have to put 45. Okay, because 46, then the next the day previous to that is 45. If I go on this side, okay, again I can put 45, no issues. If I go here, I put 45, no issues. Okay, so here all of them just one day before the late start, you will put it here in all three cases. Then 45 minus 5, you got 36. 45 minus 5, 41. 45 minus 20, okay, sorry, minus 15, sorry. 45 minus 10, 36. 45 minus 5, 41. 45 minus 15, 31. 15 is the duration, right? Okay, so you got this one. Okay, and you keep on moving. Now I want to jump to activity A. Okay, because no, not activity A. Let me see. Okay, where do I have something here? I don't have it. Okay, activity A, no problem. Activity A, no problem. Okay, so you keep on doing this. Okay, or activity C. Can I have something on activity C? Yeah, you can see the conflict on activity C. So in this case, I was getting 45 for all the three activities here. If I go to activity C, so I have 41 here. If I go one day before, it should be 40. Okay, and if I go from here, okay, it should be one day before 35. Again, you have to correct it in your notes. Okay, this one should be 35 for both cases. Okay, the early finish as well as the late finish. 35, it should be 35. Okay, so if I go back from here, it should be 35. If I go back from here, it should be 40. Okay, now if I write 40, I am breaking this rule, breaking this dependency. I'm not satisfying it. Okay, so I have to put 35 here. So 35 will satisfy both of them. Okay, because this one will be after 35 and this one is also after 35. Okay, 41 is also after 35. So I don't have any problem with that. Okay, so when you are deciding about the early start times, okay, for the early start times, and you have multiple options, you will opt for the last one, the latest one, the one which is gives you the latest date. And if you want to go for the late finish time, then you will opt for the earliest one. Okay, so they are opposite. Okay, so when you are going forward, you will look for the time which is the latest one. When you are going backward, you will look for the time which is the earliest one, because that will satisfy all the conditions, all the dependencies. Okay, same thing, I'm jumping to activity A now, so you will keep on moving backward, and the same thing will happen at activity A. I'm getting 25 from here, I'm getting 10 from here, I'm getting 30 from here. Okay, so if I select 30, I'm violating this dependency. Okay, and I'm also violating this dependency as well. Okay, because this activity has to start then after 30. Okay, if I put 10, then I'm violating this one and this one. If I put if I put 10, I'm fine. But if I put 25, if I put 25, then I'm violating this one. This one and this one. Okay, if I put 25 here, I will violate the dependency of B, because this has to start then after 25. Okay, so when I put 10, I satisfy all three of them. Okay, 10 is before 26, 10 is before 11, and 10 is before 31 as well. Okay, so when we are calculating the early times, when we are going forward, this is called as a forward pass. Okay, for early times. And when we are calculating the late times, so we are going backward, right? So we call it the backward pass. Okay, so the forward pass and the backward pass. Okay, so the first one we did was the forward pass, which gives you the duration of the project, and the last one which we did was the backward pass, which gives you the late times. Any questions? Any questions? Okay. You just, whatever is the early finish of last activity, that becomes the late finish of the last activity as well. So they are always same. These two are always same. So when you did the forward pass, you got 65. You put 65 as it is in the late time as well. This is how we initiate. What else? Any other question? Okay, though I can move on now. So now once you have these times, you can calculate something which we call as total float, and there is one thing which is not shown here, which is called as free float, and then there is the last one which is called as the drag, okay, which is the delay amount. Okay, so the total float is basically or these will be explained later as well. I believe they are somewhere here, because I want to show with the, let me just check. Okay, I just want to show with the example or something. Yeah, okay, so they are here. Total float means the amount of time activity can be delayed from the early start without delaying the project finish date. Okay, and the free float is the amount of uh, time the activity can delay without affecting the next activity. Okay, so this is for the full project and this is for the next activity. So for total float, you take the difference of the early times, the late time minus the early time. The difference of late time minus the early time. Okay, and the free float is early time of next task minus the late time of the earlier task. Okay, let me show it here. So again, pay attention. Okay, so if I want total float, you can see total float is 15 here, right? So how did I get this? 40 minus 25, 15, okay? And 26 minus 11, 15. Any one of them should give you the same answer. Total float here, 45 minus 40, okay? And if I do it here, there's zero total float as well. Now you see here for this activity, activity C, how much is total float? 36 minus 36, 0. Okay, so total float is the early time minus the late time, any one of them, either start to start or finish to finish. Okay, this will give you the total float, and it can be 0 as well. It can be 0 as well. Okay, so what does it mean? If I delay activity F by 15 days, it will not affect the last day of the project. The project will still finish on day 65. Okay, so total float shows you that you can the amount of time you can delay the activity without delaying the last day of the project. Okay, and how do we get it? Late time minus early time. Late time minus early time. Okay, so either late start to early start or late finish to early finish. Okay, then you have total float, free float as well. It was shown in the slide. It's not written here, but since we are going through this topic, let me explain it. Free float is the difference between these two times, which are at the end of the arrows. Okay, so free float is 36 minus 25 for activity G. Okay, free float is for activity F, it will be 36 minus 25. So I can delay activity F by now remember this should be 35. Okay, I told you this is a mistake. So the actual one is 35. So 25 minus 35 means 10 days. So I can delay activity F without delaying activity G by 10 days. By 10 days. Okay, same thing here. So 36 minus 36, 0. So if I cannot delay activity by any day without delaying activity D. Okay, for H, 25 minus 46, so it gives you 20 days. Okay, so I can delay activity H by 20 days. It will not affect activity E up to 20 days. Okay, so this is how we, this is a free float. This was a free float. Total float, I told you the difference of these two. Okay, now there is something which you call as drag here. To explain drag, I have to explain to you the concept of critical path. Now you can see there are some arrows which are shown with red, and they are the critical path. Okay, what is the critical path? The path along which the activities have 0 total float. Okay, critical path is the path along which the activities have 0 total float. Okay, so if I take late minus early here, 0, 0, 0, 0, 0. Okay, so all activities along this path have a total float of 0. One evidence, there's a critical path. Another evidence that the path or the duration which you get along the critical path is the highest one. So if I add the duration of all activities along this path, okay, this will be the highest duration of the project. Okay, so if I add 10 plus 20 plus 5 plus 10 plus 20, it will give me 65. Okay, if I add from here, now this is another path, right? Another path. So 10 plus 15 plus 5 plus 20, this will not give you 65. It will give you less. If I go with this path, 10 plus 15 plus 20, again less than 65. Okay, if I go from this path, A to B to C, then G and then E. Okay, it may give you 65. Let me see, 10 plus 20, 30, 35, 40, 60. Yeah. Okay, so any path which is not the critical path will give you lower duration than the critical path. Okay, so there are two conditions of the critical path. Okay, there are two conditions of the critical path. The first one is all activities along the path have zero total float. Second condition, the sum of durations along critical path is the highest than any other path. Okay, so you have to look at the sequence of activities which meet these two conditions, and you can see there are multiple sequences here: A F G E, A H E, A B C G E. These are different sequences. Okay, so you have to go through all the sequences and you have to look which one meets both the conditions. Okay, it has to meet both the conditions. One is not enough. Okay, so now in this case, the critical path which meets both the conditions is A, B, C, D, E. Okay, clear? Now what is drag? Why I explained critical path because it is connected with the concept of drag. Okay. So drag means that the amount of time by which an activity can be shortened, the duration of the activity can be shortened without affecting the project or without affecting its inclusion in the critical path. Okay, so what is drag? The amount of time you can reduce the duration of the activity without affecting its position in the critical path. Okay, so for example, what does it mean? If the duration and the drag are same amount, that means I cannot reduce the duration of this activity without removing it from the critical path. Okay, if the duration and the drag both are same, that means the activity is non-negotiable. It cannot be removed from the critical path. Okay, so for example, if you take activity B, okay, so activity B, you can see I can reduce it up to 15. I can reduce activity B up to 15. Up to 15, it will remain in the critical path. Okay, if I reduce it to 14 days, then this activity will become the longer one. Then this will become the critical path. Remember, I told you one of the conditions of the critical path is what? Summation of durations gives you the longest duration of the project. Summation of the duration gives the longer duration of the project. So if activity B is reduced from 20 to 19, it will still give the longest duration compared to the other activities, compared to the other ones. Okay, so compared to this one and this one, I still go with activity B on the critical path. It is still the longer one. Okay, if I go with 18, 17, 16, same thing. Up to 15, same thing will happen. Up to 15, same thing will happen. Okay, and then after 15, then it starts to change. If I make it 14, then this activity is longer. Okay, and this activity is also longer than 14. So automatically either this one will come in the critical path or this one will come in the critical path. Okay, because I have to keep the longest activity, right? I have to keep the longest activity in the critical path. Okay, so drag is the shortest duration of the activity. Okay, keeping its position in the critical path. Okay, at which it will still keep its position in the critical path. Okay, so and if drag and duration both are same, that means this activity cannot be removed from the critical path and its duration is not possible to be shortened. Okay, and if you want to see how much an activity can be shortened, you have to look at the parallel activities. So with B I have parallel F and H. Okay, So if I remove or if I shorten B up to 15 days, it will still be on the critical path because other activities are still equal or more than this. Okay, but if I make it 14, then I have other parallel activities which are longer. So they will come in the, they will become the critical ones, not B. Okay. If I go from for which one now? Okay, here duration drag same, no compromise here. Okay, here, okay, if I look at duration 10, okay, I have other parallel activities, this one, okay. Now this one has a duration of 5. So if I shorten this to 9 or 8 or 7, it is still more than 5. So it will remain critical. But if I make it less than 5, then this will become critical because I have to keep the longest duration activity in the path. Okay. So once you do the forward pass and the backward pass, you know the duration of the project. You can calculate total float, and then you can identify the critical path as well. Critical path has all activities on its way with zero total float, and the summation of its durations is more than any other path. Okay, the summation of its duration will give you the last day of the project. So if I sum 10 plus 20 plus 5 plus 10 plus 20, I'll get 65. Okay, no other path will give you more than this. Okay, so total float equal to 0 and the summation gives you the duration. You meet two conditions, you know the critical paths now. Once you know the critical path, then you can find out how much an activity can be shortened. How do we know that? You look at that activity and you look at if there are any parallel activities here. A, no parallel activities, so no shortening possible. B has two parallel activities. Okay, so I can shorten the activity up to the parallel activity duration. Okay, so I can shorten B from 20 to 15. Okay, here no parallel activity. D has a parallel activity. Okay, so there is a difference between duration and drag as well. Okay, so if I shorten B up to 5, it will remain in the critical path. If I do less than 5, okay, then this one will become the critical one because the summation of duration has to be longer. Okay, so this is how it is done. I've explained you forward pass, early times, backward pass, late times. I've explained you critical path, total float, free float, and drag. Any questions from any of these things? Okay, so everything is fine. So we can move on now. Okay, this is what we did, what is called as critical path method, CPM. CPM. Now I'll give you another example for CPM, which will be part of the PERT. Okay, it will be part of the PERT method. For late, okay. Let me go here. So late will finish from late times will start from here. Okay, last activity. Last activity has the last time 65. So I'll put 65 here. Okay, 65 same, no calculation. 65 minus duration, I get 46. I put 46 here. Okay, now from 46 I can go here, I have to go here, I have to go here. Okay, so 46 previous day 45, 46 previous day 45, 46 previous day 45. Okay, now so I have the finish time, I want the start time 45 minus duration, 45 minus duration 41, 45 minus duration 10, 36, 45 minus duration 15, 31. Okay, now from here I have 41, I can go here, and I have 36 here, I can go here. Okay, and I can go here as well. So 41, if I go here, 40, no problem. I don't have any other arrows here. 41, I come here, if I put 40, I have another arrow here, so I have to look for this one as well. So from here, 41, I can go to 40 here, I can write 40 here. Okay, but will it meet this condition? No. From here, 36, the last day will be 35. The previous state to 36 will be 35. So I'm getting 40 from here and 35 from here. Okay. So when I'm doing the backward pass, I always take the earliest time. Okay. So I can take 40 or I can take 35. I'll go for 35. Okay. So is it clear? I have explained now a number of nodes. Okay. And where I had the other one as well. It is possible. It is possible, but not okay. It is possible to have two critical paths where it will make the life of the project manager miserable. Okay, it will have problems. Okay, so multiple critical paths happen when you try to use the drag. Okay, so now you see here, this is a drag. If I use the drag of B and I reduce it to 15, okay, I may have two critical paths because this one is also 15, this one is also 15. I can end up with two critical paths. Yes, it is possible. It normally happens when you try to use up the drag. Okay, when you try to use up the drag completely. So I can reduce it to 14. Let me reduce it to 14. Oh, sorry, I can reduce it to 15. Let me reduce it to 15. Okay, then in that case, you may have two critical paths. But that is not ideal. It will make your life miserable as a project manager because you have to handle multiple activities of the same importance. Two critical path means parallel activities with same importance level. So this is very difficult to manage on the construction site. Any other question? Okay, moving on. What we have done here is called the critical path. What was the most important point here? Every activity has a single estimate of duration. A is set to finish in 10 days. There is no other possible value for duration of A. Okay. So the sorry. Okay, so in critical path method, in the traditional critical path method, we don't consider any chance that an activity may have multiple possibilities of duration, which is more realistic idea, right? Realistically, your concreting may finish in 5 days, and it is a chance that it can also finish in 6 days, and there's a chance that it can also finish in 4 days. Okay, so in real world, everything is not fixed. You know that, right? So that's why they came up with another technique which is called as PERT, Program Evaluation Review Technique. The difference between PERT and the CPM is that PERT assumes multiple durations of the same activity. So there are multiple possible durations of the same activity. Okay. Now, when you are dealing with multiple chances, there are two ways to deal with it. One is you assume that the chances are equally divided. Chances are equally divided. We call it normal distribution. So according to normal distribution, chance of any outcome of the activity has equal chances compared to any other outcome. So if there are three possible chances for an activity that can finish in 4 days, 5 days or 6 days, all these three values have equal chances. This is the idea of normal distribution. Okay, some of you have taken traffic engineering with me. I have shown you this normal distribution graph. Okay, and for traffic speeds. Okay, so this graph represents equal chance distribution. Equal chance distribution. Okay, this is what we normally assume for real world data. But in construction, are we looking to waste our time? Is the manager looking to waste the time? No. What we are trying to do, we are trying to save the time. Okay, the manager or the person who is working on the site is trying to save the time. So there are more chances that the activity has lower duration and there are less chances of activity having higher duration, because higher duration is problematic for everybody. Client doesn't want it, project manager doesn't want it, contractor doesn't want it. So everybody is trying to reduce the time of the activity. So the higher chances are for lower durations and lower chances for higher durations. So this is represented by another distribution which is called as beta. Okay, so the core concept of beta distribution is then at activity has higher chances of lower duration because everybody is trying to work as fast as possible, and there are lower chances of higher duration because nobody wants to delay. Okay, so this is the main difference between distribution of chances in normal cases and in construction activity duration case. Okay, so PERT assumes that there are multiple chances of an activity duration, but they are not following normal, so the chances are not equally divided. They are following beta distribution. Okay, so in beta distribution the peak is somewhere near the start of the duration, somewhere near the lower duration. Okay, so we call it the most likely time, the most likely time. Okay, everybody is trying to achieve this much. Okay, and then there is an optimistic time as well, which is the absolute minimum of duration of the activity. You cannot achieve this activity in less time than this. We call it optimistic time. And then there is pessimistic time, which is the absolute maximum time of an activity. Absolute maximum time of an activity. You cannot do it more time than this. Okay, remember we are talking about duration of the activity, not the delay when the activity is stopped. Okay, so stoppage is not included here. Okay, so beta duration follows this one, and this is what we assume. So according to PERT, the mean time of an activity, they call it the expected time. The expected or the mean time of the activity depends upon three values: optimistic time, absolute minimum; most likely time, the top most time everybody is trying to achieve; and the pessimistic time. Okay, the highest time of the activity. Okay, so what is the mean or average duration of the activity? The expected duration of the activity, it will be calculated using this equation. Okay, so and the variance in the duration is calculated using this: pessimistic time, optimistic time divided by 6 square. Okay, so you can see it's not a normal average here. In normal distribution we take the normal average, this plus this plus this divided by 3. But here you can see this is weighted average because of the beta distribution. Okay, so we have 3 times: best time optimistic, worst time pessimistic, most likely time, which everybody is more confident about, TM. Okay, most likely time. But when you are doing the calculations for your timeline, you will not take any one of these values. You will do a weighted average of them to put it in your network. Okay, so in the network analysis, the one which we just did, you will not use T naught or TM or TP. We'll use TE, the expected time. Okay. So any questions? Okay. So for PERT, we draw another diagram which is called as activity on arrow. So you can see this is different from the diagram which we have plotted earlier. That one was called activity on node. This one is called activity on arrow. Okay, activity on arrow. So in this diagram, you can see the activities are on the arrows. Alphabets are the activities and they are on the arrows. Now what is this 1, 2, 3, 4, 5? These are called nodes. They are called as nodes. Okay. So each arrow has a duration, right? Each arrow has a duration, okay? And each node, each circle here is either representing the start time or the end time of the activity. So one is the what they call as the tail event, okay? So for activity A, node 1 is its starting event, meaning its tail event, and number 2 is the end event or the head event. These terms are written here, okay? So the node which is at the end, we call it the tail event or the end event, and the node which is at the start, we call it the node which is at the end, we call it the head event or the end event. The node which is at the start, we call it the start event or the tail event, okay? So every activity is on the arrow. Every arrow has two nodes attached to it, okay? And one arrow can go to, multiple arrows can go to the same event if the activities are interconnected, okay? So this one, for example, is showing that H, the start event of H depends upon E and F both. You can see 6 is the start event of H and 6 depends on E and F both, okay? Then 7 is the end event for H and is also the end event of G as well, because J depends on both of them, okay? Activity J depends on both of them, okay? So you have to look if one activity depends upon multiple ones, then it will start, or those multiple activities will end on the same node, okay? So J depends upon two activities, so those two activities will end on the same node. Similarly, H depends upon two activities, so both these two activities will end on the same node to show the multiple dependencies here, okay? Then we have the concept of dummy activity, okay? Dummy activity is inserted in the diagram just to explain that two nodes are different from each other, okay? I don't think we have an example for this one here, but just to give the concept. For example, I have two activities here, activity E and activity F. Both are ending on the same event, 6. For some reason, I want to show that the end of activity E is not the same as end of activity F. So I have to now make two events. When I make two events, I have to link them, because I have to then link it to activity H, both of them, okay? So I will make another event here. Let me do it. I hope it will. Okay, so I will make another event here. I'll take E here, okay? So it shows that yes, E end is different, F end is different, okay? So this one will not be here. But now I know E is connected to H and F is also connected to H. So I separated the end event, but in the end I have to connect them for H. So now this arrow becomes a dummy activity. This arrow becomes a dummy activity. So it's not an activity, but it's just a method to connect two events which are different from each other, okay? If you don't do it, then that means that end of E is the end of F and both have no difference in them if I don't do the dummy activity here, okay? So okay, what other concepts we have here? Okay, I already told you about dummy activity. Every activity should have a start node and an end node, okay? The start node of the network and the end node of the network, okay? So the network should have only one start node and one end node. Even if you have multiple critical paths, they should all end at the same node. So you can see activity, node 1, it has multiple activities, but the node is 1. Node 8, end of the project, it has again multiple activities, okay, but they are ending at one node, okay. So a start node and end node of the project should be 1 in each case, and each activity should have either a unique start node or a unique end node or both of them. So an activity cannot have the same start and end both same as the other activity. Okay, an activity, so I cannot have something like this here. So this is A and I make another one again starting from 1 ending at 2 same as A, but I'm saying no, it's not A, it's activity Z. So this is wrong. This cannot happen. Okay, activity Z is nothing, activity Z is A. Okay, you are just making your life difficult here. Okay, so this is okay. Okay, so I will start this process next time. Okay, because yeah, it will be better in this way. So any questions you have? Anybody has any questions?